What is going on, guys? It's Bucky and welcome to your 8th physics tutorial. And in this tutorial I want to talk to you guys about something called significant figures. Now, a significant figure is basically a way of saying how precise should your answers be whenever you're working with scientific notation. So before, when we were working with scientific notation, we got numbers like 1.53217, and maybe those numbers went on and on forever. Well, if you're saying, all right, so how do I know how many decimal places I'm supposed to write in my answer? Well, there actually is an answer to that question, and it isn't just basically however many you feel like. There's actually a rhyme and a reason to it, and it makes a lot of sense. So hopefully by the end of these tutorials, you guys are going to understand the importance and the significance to significant figures. Should I have said it like that? Probably not, but you guys know what I mean. So basically, let me go ahead and tell you a story from my childhood, and this is gonna, definitely explain to you guys how and why significant figures are important. So when I was in high school, I used to be on the wrestling team, and I was always obsessed about my weight. So I had a scale at my house that I weighed myself multiple times a day. So one day I weighed myself and the scale said 165 pounds. It only had enough data to round it to the nearest pound. Again, if you wanted to buy a scale that, gave you a tenth of a pound, like 165.175, those cost like thousands and thousands of dollars to get a scale that accurate. So we only had, a dumb scale that we bought at Kmart, so it only gave us my weight to the nearest pound. So I walk into wrestling practice one day, and my coach says, "All right, Bucky, how much do you weigh?" And I tell him 165 pounds. And he looks at me. I look a little bit chubby, like I'm overweight, like I'm not going to make weight for the tournament. And he says, "You know what? I don't believe you. Get on the scale." So I go ahead and hop on the scale, and if you never wrestled in high school before, they have really precise, expensive scales. So, in fact, whenever I got on that scale, it said 165.38. So he's like, Bucky, you lied to me. You told me you weighed 165, and whenever I said that, he was assuming it was 165.00, when in fact I weighed more than 165. So was I lying to him? Well, I wasn't exactly lying to him, but the results were different. So, with that being said, that is basically the importance of significant figures. Whenever you're working with significant figures, you can only claim your answer to be as accurate as the least accurate factor. And you're going to see what I'm talking about whenever I'm working with this in scientific notation. But basically, what I'm trying to say is whenever you're using scientific notation, especially with multiplication and division, your answer can't be more precise than your least precise factor. And by that I mean you can't assume this number is 165.00 because we don't have the equipment to verify that. We can only assume, we can only basically work with whole numbers since this information right here is unknown. So we can't just claim it to be whatever we want it to. So let me go ahead and give you guys another example. Go ahead and change my color a little bit. No, change it to green or something like that. So basically, say you and your friend wanted to start I don't know, like selling potatoes on the side of the road. Like that's a good idea. So you go ahead and I'm going to go ahead and weigh all the potatoes I own first. And remember, I have that cheap scale from Kmart or Walmart, wherever I said I got it from. So I only can weigh to the nearest whole pound. So it says I have 20 pounds of potatoes. Pretty cool. So I call up my friend, and his dad is a doctor. He always gets the nicest clothes, the nicest shoes. So he has this super fancy mega scale. So he weighs his potatoes, and of course, he has more potatoes than I do. He has 32.87 pounds of potatoes. So we say, all right, we're going to go ahead and add up our potatoes to see how much money we can make. However, we can't say that we have 52.87 pounds of potatoes because that number may or may not be accurate. And the reason for that is because, if you guys don't understand, this 20 right here, it may or may not be 20.00. This number 20, accidentally deleted that. Okay, let's clear this up. This number 20 right here can be anything from like 19.5 to 20.49, and we really don't know to add 19.5 to this or to add 20.49 or anything in between. So really, all this information to the right of the decimal point is pretty much just a guess. So the only information that we really want to work with is this. What we need to do is, whenever we add this together, what the heck? Together, we basically need to round, in other words, get rid of this. So we can only say we have 53, and we can't even use a decimal place. We can only say we have 53 pounds of potatoes if we want to round, or to be on the safe side, we can just say we have 52, and it will work out like that. But basically what I'm trying to say is, whenever you work with significant figures, you can't claim to have more information than you really do, because these numbers right here are basically just question marks. So you can't just go ahead and throw in anything there you like. You can only have an answer that's as accurate as your least precise piece of equipment. So that's basically what I'm trying to say. Hopefully you understand the importance of significant figures and why and how we need to use them. So in the next tutorials, what I'm going to be doing is I'm going to be showing you a real quick example of multiplication and division, and I'm going to show you how what we did in the last tutorials were wrong and how to correct it. So with that being said, thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next tutorial.